Okay, hello all. Let's start chapter 2. Our chapter 2 is 2.1 derivatives and rate of change. We are done with the first topic of calculus, which was limit. Now, slowly, we are moving to learn derivatives. What is a derivative? What does it mean? Let me start with the tangent line again. We did it before, but once again, let me start with the tangent line. If you remember at the beginning of chapter 1.5, I explained for you what is a tangent line and how to find the slope of the tangent line at a given point. One more time, I will show that graph for you, and slowly we will do a jump from tangent line to derivatives, correct? For example, if I draw again my graph for you, my curve for you, the curve that I used before. This is X, this is Y. Let's say we have a curve like this. This is a function f of x, correct? We had 2 points. We named this point P, and we choose another point and we named it Q, remember? With a slight difference, I'll name this point, the coordinates of this point on X as A, and I'll name the coordinates of Q on X, X. Based on algebra, if this point is A, if I ask you how much is the value of A on the Y, definitely the answer is what? F of A. For example, if it's 1, if it's a square root, y equal x squared, it gives you 1, right? If this one is x, the coordinates on the y will be f of x, correct? Now, if I draw a triangle here for you, if I connect this point like this, and if I draw the secant line here, and we already discussed what is secant line, a line that crosses a curve and 2 points, correct? You see here a triangle like this. Now, if this is f of a in a right triangle, you know, if it's a right triangle, correct? If you are looking for the slope, the change in y over the change in x gives you the slope. The slope formula was m equals delta y over delta x. I'm sure you see this notation before. Delta y means change in y. Delta x means change in x. Delta y means y2 minus y1, change in y. Delta x means x2 minus x1. Now, let's change these names a little bit, right? Let's change it. Let's look at our graph. If this is A, delta y will be what? Your delta y is, actually this point is your x2. If I name it with the red, this point is x1, this point is x2, then this one becomes y1, this one becomes y2, right? Now, if I want to write the formula, the slope for the secant line, if I name it MPQ, MPQ equals y2 minus y1. It means f of x minus f of a over x2 minus x1, which is x minus a. This formula is the slope of the secant line. Remember, when I start with limit, I said, oh, if you want to find now the slope of the tangent line at point A, which is this black line, right? If you want to find the slope of this tangent line, we are moving point Q closer and closer and closer to where? To point A. X goes closer and closer to A. Remember, I translated for you closer and closer, or X approaches to A. This is the idea of the limit. Then, if I want to talk about the slope of the tangent line, I can write this formula for you. M equals limit as X approaching to A. You see, X approaching to A. F of X minus F of A over X minus A. That will be the formula to find the slope of a tangent line in a given point. If someone gives you a point on a curve and they ask you, okay, find the slope of the line and write for the tangent line and write the equation for the tangent line, this is the formula to find the slope. And of course, to write the equation for the tangent line, we always use this. Y minus y1 equals m times x minus x1, your slope point formula to write the equation, correct? It's that easy. Now, let me bring a little bit change in my graph, correct? I'll name it this time different way. I want to introduce a formula for you that actually you saw it before in college algebra and pre-calculus. Those of you that you came from high school directly to us in MSGC, you saw this formula maybe in algebra 2, correct? Again, same curve. This is my point P and this is my point Q. Let's draw the secant line passing from these 2 points, correct? The coordinates of P on x-axis, let's name it A. If this point, I name it A plus H, right? H is a difference between this point and this point. I can introduce it to you. This distance is actually H. It means here you have H, correct? If this point is A, then the coordinates on the y-axis will be f of A, right? Same idea. If this point is H, the coordinates on the y-axis will be f of A plus H, right? Now, if I want to write the slope formula, now I will write m equals limit. You see this distance, I name it H. This side is H. H is going close and close to A. It means actually your H, this distance becomes 0 when you, if this is the starting point, correct? When you come close to this point, it means H is approaching to where? To 0. Now, what we have in the top, y2 minus y1, it means f of A plus H minus f of A over, instead of x minus A, here you can write H. That will be also the slope, because I used limit, that will be the slope of the tangent line at the given point. Do you see this? Do you see this formula before? Did you saw this formula before? F of A plus H minus F of A over H. That was the difference of quotient formula, difference quotient formula. On that time, it was really difficult to prove it for you. Your professor, I'm sure, didn't prove it for you. Why? But right now in calculus class, you have the understanding of limit and you know what does it mean. Later, I'll introduce in next few minutes, I'll put a new name on this formula. Up to now, we just know it as the slope of the tangent line, correct? You can use this one, or you can use the first formula that I proved for you to find the slope of any tangent line and write the equation of the line. Let's do an example to practice with this formula. Example number 1. Find an equation of tangent line. Find an equation of tangent line to the parabola y equal x squared, or f of x equal x squared at p 1, 1. I want to find, even I'm not graphing now this problem, I want to find the equation for the tangent line that passes through the point 1, 1 of this curve. Y equal x squared, everyone knows it's a parabola, right? To start with, my formula, the slope formula that I proved for you, m, the slope of the tangent line, m equals limit as x approaching to a. If I use the first formula, f of x minus f of a over x minus a. That's my formula. How much is the value of x? This is the value of x, right? The value of a. This is the point. A, 1, 1. Your a is 1. Then let's plug in the value of a here. Then you can write limit as x approaching to 1, your a is 1, f of x. What is the value of f of x? The value of the f of x is given to you. Value of f of x. Here, this is your f of x. Y or f of x, right? F of x equal x squared. Then I will write here x squared, then minus f of a. How much is f of a? You have to calculate. You see, I'll show it to you. You have y equal x squared, or even you can write f of x equal x squared. That's a good notation instead of y. If I ask you find f of 1, can you find it? F of 1 equals 1 squared gives you 1. Then your f of a is how much? 1 over x minus a 1. An easy limit for you. Now you have a lot of practice with the limit laws, right? You see, you cannot directly substitute the value of x, because if you plug in here in the denominator 1 minus 1 gives you 0 undefined, then you have to use an algebra technique. What you can do, you can factor the top. Then keep your limit as x approaching to 1. Factor the top, which is x plus 1 times x minus 1 over x minus 1. Here, x minus 1 cancels out with x minus 1. It means you end up with limit of x plus 1 as x approaching to 1. Now plug in the limit here. Do not write the sign of limit. It means 1 plus 1, which gives you what? 2. This is actually the slope of the tangent line. The slope of the tangent line is how much? 2. Now, I will use my formula, y minus y1 equals m times x minus x1, and I can write the equation of the tangent line really, really easy. Y minus y1. You had a point P11. This is your y1, right? That means y minus 1 equals m. How much is m? You already found it, 2. Times x minus x1. How much is x1? 1. That means y minus 1 equals 2x minus 2. It means y equals, if you simplify this, y equals to x minus 1 will be the equation of the tangent line that passes the parabola y equal x squared at the point 1, 1. Correct? That easy. Let's do another example. For example, if example number 2, if f of x equals 3 over x, find the slope of the tangent line at the point 3, 1, 3, 1. Correct? This time I'll use the other formula, this one. M equals f of x plus h, right? Or x plus a, we name it here x plus h, minus f of x over h. Sorry, I have to put the limit sign before that because I'm talking about the slope of the tangent line. Then m equals limit of that as h approaching to 0. Correct? Focus here because it's kind of, some professors, they put everything at once in this fraction. It gets difficult for students to even understand from where these values came in. Let me explain it step by step for you. Look at your formula. You need to find first the f of x plus h. And also you need to find f of x, correct? Even before that, you can do one more step, m equals limit, because you have some values, h equals, h approaching to 0, f of x plus h. How much is your x? Your x is given to you as a 3. 3 plus h minus f of 3 over h. Now, you need to find f of 3 plus h and also f of 3. Then you can plug everything in this formula. I'll do it in the side here. Look, your function is f of x equals 3 over x, right? Everyone knows this. If I ask you to find f of 3 plus h, I'm sure all of you know how to find it. It means replace x with 3 plus h. It means this one will become 3 over 3 plus h. Again, your function is f of x. If I ask you to find f of 3, it means replace x with 3. It means it gives you 3 over 3, which is what? 1. Let's bring these two values, which is this one and this one, and plug it to our formula and see what's happening. Then I can write m equals limit as h approaching to 0, f of 3 plus h gives you 3 over 3 plus h, minus f of 3 means 1 over what? H. After this, it's not calculus, right? We are now dealing with algebra. Let's simplify this. You need a common denominator in the top. Your common denominator will be 3 plus h, here times 3 plus h, correct? Then you can write m equals limit as h approaching to 0, common denominator 3 plus h, and the top you have 3 minus parentheses 3 plus h over h. Distribute the negative to inside, then limit as h approaching to 0. Let's simplify the top. Denominator is 3 plus h. 3, distribute the negative, minus 3 minus h over all over h. Negative 3, positive 3 cancels out. It's given as a 3 plus h. Yeah. Then you can write limit. Let's simplify this. You have as h approaching to 0. In the top, I can write negative h over 3 plus h, right? And change the big fraction word to times and flip this one, 1 over h. These two cancels out. Then you can write limit as h approaching to 0 of what? Negative 1 over 3 plus h. If you plug in h0, that gives you negative 1 over 3 plus 0, which gives you negative 1/3. That means the slope of the tangent line at that point will be negative 1/3, correct? Two examples should be enough to give you the idea of the tangent line. Same thing, they talk about velocity. I don't want to discuss it now for you. It's too early to bring physics and the calculus. You are too new with. I'll wait because this topic comes again in future. I will not discuss the velocity problem here with you. I'll give you time for that. And next chapter or chapter after that, we will discuss that topic definitely, even it comes back in calculus too, how to use derivatives in physics. We will discuss that later. Let's now talk about that was all about the tangent line and the basic idea of what is derivatives of a function, correct? I will stop the lecture here for you and I'll jump to 2.2. 2.1 was all about the tangent line and the slope of the tangent line. Let's just stop our lecture here and let's start. In next lecture, I'll explain to you what is the meaning of derivatives, okay?